Welcome back to Simo. Welcome back to this channel. Today we are going to solve a paper 1 question on ENSPY, that's the 2019 session, and the question is displayed on the screen. So that was exercise 1 and it's 4 marks. The question reads: A, B, C, D are such that we have A, B, C, D as seen on the screen. So A is the square root of 4 minus the square root of 5 minus A. B is the square root of 4 plus the square root of 5 minus B. C is the square root of 4 minus the square root of 5 minus C. And D is the square root of 4 plus the square root of 5 plus D. So here's D. Now they're asking us to show that A and B are roots of the equation x to the 4 minus 8x squared plus x plus 8 is equal to 0. Show that C and D are roots of the equation y to the 4th power minus 8y squared minus y plus 11 is equal to 0. And lastly, deduce that the product A, B, C, D is equal to 1. Okay, so let's start with the video. So the first is we want to show that A and B are roots of the equation. Now if A is a root of the equation, then it simply means that f of A will simply give us 0. Now if f of A gives us 0, in other words, it means that A is going to satisfy this equation. So what do? We are simply going to replace A wherever we see x, and we expand and verify if it's going to give us 0 or not. If the result is 0, then it means that A is actually root of the equation. So let's do that. Now recall, A is the square root of 4 minus the square root of 5 minus A. All of that in square root. So we are going to replace it in our function. So I'm going to let f of x be my function, x to the 4th power minus 8x squared plus x plus 11. Now verifying if f of a is equal to 0. So here we don't know, but if it gives 0, it means that a is a root. Now replacing the value of a, f of a will simply be equal to, wherever we see x, we replace by a, and my a is the square root of 4 minus the square root of 5 minus a all of that raised to the power 4 minus 8 into square root of 4 minus the square root of 5 minus a, all of this squared. My x is a, so plus a plus 11. So this means that f of a will be equal to, so this is 4 minus the square root of 5 minus a, all of that squared. Since the 4th root, this to the power half, the 4th root times half will give me 2. So it means will be squared here. So here the square root we cancel off with the square. So you'll be left with 8 into 4 minus the square root of 5 minus a, then plus a plus 11. So this means that my f of a will be equal to, let's expand. So expanding this bracket, we have 16 minus 8 root 5 minus a, then that will be plus 5 minus a, then we expand this other bracket, so what we get is minus 32. Let me write it in another ink. Here we have minus 32 plus 8 root 5 minus a. So I've expanded this side, then plus the last part, which is plus a plus 11. Now let's simplify and see what it gives. Now 16 plus 5, that's 21, minus 32 gives negative 11. Negative 8 root 5 minus a plus 8 root 5 minus a we cancel. Negative a and a we cancel. So I'll be left with negative 11 plus 11, which is 0. Hence f of a is equal to 0. And then what then do we conclude? Since f of a is equal to 0, then x is equal to a is a root of f of x as required. Now the next, the b part says we should also show that b2 is a solution. Now we are going to do the same thing. If b is a solution, it means b should satisfy that equation. There is another possibility of doing this. Let me show that. Now if b satisfies the equation x to the power 4 minus 8x squared plus x plus 11 minus 8x squared plus x plus 11 is equal to 0. Now you can try this this methodology again, it will still give you the same thing. Now if b satisfies this, for example, it means that at the end, b, if we plug in b, we are going to have b to the power 4 minus 8b squared plus b plus 11 is equal to 0. So this means that b also satisfies that equation. But recall, what was b? B is equal to the square root of 4 plus the square root of 5 minus b. So it is the square root of 4 plus the square root of 5 minus b. Now let's verify if we expand this, what is it going to give? Can it be able to come out with an equation of this sort, such that we can pose x to be equal to b to be root? So let's verify. So if I square both sides, this means I will have b squared is equal to 4 plus 5 minus b, all of that raised to the power half, that means square root. Now if I subtract 4 from both sides, I have b squared minus 4 will be equal to 5 minus b raised to the power half. If you square both sides, we have b squared minus 4, all of this squared will be equal to 5 minus b, since the square root will disappear with the square. Now this means, let's expand, the right hand side, sorry, the left hand side will become b to the power 4 minus 8b square plus 16 is equal to 5 minus b. So if we rearrange, we are going to have b to the power 4 minus 8b square plus 16. Now here we are going to have minus 5 plus b is equal to 0. So what does it give? It means that we have b to the power 4 minus 8b squared plus 16 minus 5 is 11. So we can write it as plus b plus 11 is equal to 0. Now you see that this equation is the same as that which we had initially. That is, the initial equation was x to the 4 minus 8x squared plus b plus 11 is equal to 0. So what has happened here is there has simply occurred a change of variable. X is equal to b, and it means that if x can be equal to b and x equal b still gives 0, it definitely means that x or b is a root of that equation. Or we can still pass through the normal procedure which we had, where we are going to say that we are verifying if f of b is equal to 0. So let's get f of b. F of b will be equal to, open up your brackets, you have the square root, that was b was 4 plus the square root of 5 minus b, all of this raised to the power 4, that will be minus 8 into the square root of 4 plus square root of 5 minus b, all of this squared plus b plus 11. So this gives 4 plus the square root of 5 minus b, all of this squared, since 2 of this we cancel with the square root, then here will be minus 8 into 4 plus the square root of 5 minus b, then plus b plus 11. So what do we get here? This will be equal to 16 plus 8 root 5 minus b plus 5 minus b. Now the other side will give negative 8 times 4 will give minus 32 minus 8 root 5 minus b, all of this plus b plus 11. Now if we simplify, we realize that 8 minus 5b cancels negative 8 root 5 minus b. Now b and negative b cancels. What we have left is 16 plus 5, which is 21. 21 minus 32 gives negative 11, and negative 11 plus 11 gives 0. That's another possibility. So you have shown that b is a root. So since f of b is equal to 0, then x is equal to b is a root as required. Now the next says show that c and d are roots of the equation. Okay, root of the equation y to the 4th minus 8y squared minus y plus 11 is equal to 0. So c is 4 minus the square root of 5 plus c. Okay, so let's see that. So c is equal to 4 minus the square root of 5 plus c. Okay, now let's also verify that this is a solution of y to the 4th minus 8y squared minus y plus 11. So we have our f of y is equal to y to the 4 minus 8y squared minus y plus 11. I think that's the equation. Yes. Okay, so now we are going to do the same thing. Either we square this, you show that it can be written in this form, or you substitute. So I'm going to square this and show that it can be written in this form, then you can do the other way. So what do we have? This will imply that c squared to be equal to 4 minus the square root of 5 plus c. Now this means that we have c squared minus 4, and I'll just square it. That will be equal to 5 plus c. So this means I will have c squared minus 8c plus 16 is equal to 5 plus c. So we see this will give me c squared minus, c to the power 4, it's c squared. So that's c to the power 4 is 4, c to the power 4 minus 8c squared minus c plus 11 is equal to 0. So you see that it suffices for me to pose y equals c and the solution is out, or you do the other way around. So as your own personal work, do that for d and show that it is it. Now let's use the other methodology to get c. So we are going to replace c inside our equation, and our c is 4 minus root 5 plus c, all of them is square root. So f of c will be equal to square root of 4 minus square root of 5 plus c, all of this raised to the power 4 raised to the power 4 plus the square root of 4 minus 5 plus c all of this squared. There is no plus, it's minus there. So here we have minus, then minus c plus 11. So let's verify 0. Now this gives us 4 minus the square root of 5 plus c, all of this squared, minus there's 8 here, sorry, minus 8 into 4 minus the square root of 5 minus c, then minus c plus 11. So this means we have 16 minus 8 root 5 plus c. This will be minus 32 plus 8 root 5 minus c plus 11. Now things cancels out, this and this cancels. What else cancels? Something has been omitted somewhere. Okay, here I omitted to add the term 5 plus c. Now c and let me remove this, let me re-expand. I omitted the term while expanding. So this gives 16 minus 8 root 5 plus c plus 5 plus c. Then here gives minus 32 plus 8 root 5 minus c. C plus or minus, c is plus. Okay, so here is plus, then minus c plus 11. So so this cancels with this. Negative c goes negative c has to cancel out with positive c. Something has been omitted somewhere. 5 plus c, so here is a plus sign, so the plus will cancel with the negative, and here we have 16 minus 32, that's negative 16, plus 5, that's negative 11. So we'll have negative 11 plus 11, which gives 0. So we clearly see that f of c is equal to 0. So it definitely means that x is equal to c is a root. So you do the same for d. Okay, so you have to be very careful and keen while expanding, because any slight mistake like the one we did, that is omitting c and taking it to be minus, will really be fatal to you. So that is how you can actually prove this statement. Now let's do the last one. The last one says we should deduce that the product ABCD is equal to 1. Now I would like us to do a keen observation between these two equations. Now we see that if I pose a change of variable y is equal to negative x, for example, and I substitute y equal to negative x in any of these two equations, that is, if I replace y is equal to negative x in equation 2, I will call this, for example, equation 1, and this is my second equation. If I replace it here, it means I will have negative x all of that raised to the power 4 minus 8 into negative x all of that squared. That will be minus negative x plus 11 equal to 0. So what do we realize? We see we have x to the 4 minus 8x squared plus x plus 11. So what does it give? It gives us back the first equation. So it means that if I pose a change of variables y is equal to negative x, it definitely means that y equal negative x will satisfy all of this equation 1. So with this notion where we can let y to be equal to negative x, now we know that since y equal to c and y is equal to d are roots of this equation 2, then it means that if I pose y is equal to negative c and y is equal to negative d, this would definitely be solutions of the equation x, since we saw that y is equal to negative x, it satisfies this particular equation. So it satisfies and it transforms equation 2 to equation 1. So it means that if we pose our x now, so we are going to change our variables such that we can find the product easily. So I'm going to pose that x is equal to negative c and x is equal to negative d is a solution to equation 1. Since we saw that when I change y equal negative x, this satisfies what is above. and vice versa. And so if we pose that, if we realize it, it means that x is equal to negative c is a solution to this equation, and x is equal to negative d is also a solution. Now since the highest exponent is power 4, it means that, and we have 4 different roots, we have a, b, c and d, negative c and negative d, then we can express this in terms of the product of its factors. So from here we can see that x plus c is equal to 0 and x plus d is equal to 0. Now expressing that as the product of its factors, so it means that what do we do? That's it. So we are showing that the product a, b, c, d is equal to what is there. Okay, so to do this, as I said, we have x is equal to a, x is equal to b is a factor, x is equal to negative c, x is equal to negative d are still factors. So if we write this in terms of product of factors, we are going to have that our f of x will be equal to x minus a times x minus b times x plus c times x plus d. Now all of this will be identical to our function, that's x to the power 4 minus 8x squared plus x plus 11. Now what do? We expand this and we try to get the values of a, b, c, d. So what do we get? It means, let's expand the first two. Now the first two we give x squared minus bx minus ax, so that will be minus a plus b, all of that x, then plus a b. Then we expand the second, it will give us x squared plus c plus d, all of this x plus cd. Now this is identical to x to the 4 minus 8x squared plus x plus 11. Now this means, let's expand and see what we are going to get. This means we have x to the power 4, we have plus c plus d x cubed plus cd x squared minus a plus b x cubed minus a plus b into c plus d x squared minus a plus b times cd x. Continue. Now the last, so we have plus ab x squared plus c plus d ab x, then plus a b c d. But this should be identical to x to the 4th minus 8x squared plus x plus 11. Now we see that if you are comparing terms, x to the 4th, x to the 4th, the cubic terms do not exist, so it means c plus d will give 0. That's c plus d minus a plus b will give 0. Now we clearly see from here that the product a, b, c, d is a constant term which can be compared to 11. So therefore we deduce that a, b, c, d is equal to 11 as required. And that brings us to the end of this video. On the question paper it was written 1, but it cannot be 1, it's 11, not 1. So this brings us to the end of this video. If it is your first time on our channel, please do not forget to like, share and subscribe to get more of such content. See you in our next video.